Alright, so what if we subtract two random variables? The mean of the difference of two random variables is just what you would expect. It's the difference of the expected values. However, the variance is still the sum of the variances. So the variance of D is still the variance of X plus the variance of Y. The idea here is that you never subtract the variances. You're still adding the variances. You're fired. Copernicus is a realtor with struggling to hold on to his job. The amount of property that he sells a month is normally distributed with a mean of 13,400 and a standard deviation of 2,200. Bernoulli sales are normally distributed. An expected value of 12,200, a standard deviation of 3,500. Copernicus' boss tells him that he must sell $3,000 more than Bernoulli next month or he will be fired. Assuming their sales are independent of each other, find the probability that Copernicus gets fired. So let's take a look at the difference in their sales. And go Copernicus minus Bernoulli. First of all, the difference is approximately normally distributed. Expected value of D is the expected value of C minus expected value of the other, which is $1,200. Standard deviation. Now, I'm subtracting the variables. They're independent. So I don't add or subtract the standard deviations, add or subtract the variances. And I never subtract the variances, so I don't know. It's the square root of 2200 squared plus 3500 squared. 2200 squared plus 3500 squared. $4134. $4134. So I want to find the probability that Copernicus gets fired. That is the probability that he sells 3,000 or less. Copernicus sales are less than Bernoulli sales plus 3,000. He must sell 3,000 or more than Bernoulli. So if he sells Bernoulli plus 3,000, okay, so that's it. Now I want to get the difference, C minus B. So subtract B from both sides. So apparently I just want the probability that the difference is less than 3,000. The center is 1,200. It's normal. Standard deviation is 4134. I want the probability that its difference is difference is 3,000 or less. Yep, you better get a new job because it's not looking good. Norm. Norm CDF. Lower bound is negative infinity to 3,000. Mean is 1,200. Standard deviation is 4134. 66.8%. there's a really good chance that he's going to get fired. All right, that's the end of 6.2.